Good morning, everybody. Thank you for joining us today. Welcome to the session entitled Building an Infrastructure that Enables Innovation Through Real-Time and Scalable Architecture. That's a bit of a mouthful, but that's what happens when you let marketing come up with a title for your talk. So anyway, thanks for joining me today. If I could get my mouse to work. My name's Paul Moxon. I am the Senior Vice President of Data Architectures and Chief Evangelist at Denodo Technologies. And in this role, I talk to many organizations around the world, both in the private sector and in the public sector, the government sector, about their data strategy, their data architectures, and specifically about how data virtualization can help them build real-time, scalable, and adaptive architectures. Architectures that will change and allow innovation as business circumstances change, as technology changes, as the data itself changes. So obviously this is very, very interesting, a very hot topic. But before I go any further, I just want to talk about, my definition of adaptive. This is from the Oxford English Dictionary. It defines adaptive as an adjective that describes that an object's ability to change as conditions and circumstances change. In the case of an adaptive architecture, an adaptive data architecture, this could be the ability for the architecture to easily change to accommodate new business requirements or new data sources, new data formats, and so on. So I view an adaptive architecture as something that will embrace and enable change while minimizing the impact of this change on the users of the system itself. And obviously, if you want to innovate, if you want to introduce new technologies, if you want to introduce new ways of doing things, you need an adaptive architecture. So innovation requires you to be adaptive, flexible, and scalable. So the challenge is in most cases, getting the right data to the right people. We have lots of data trapped in silos. We've got lots of data trapped in legacy systems. Data provisioning is via replication. It's that nightly ETL jobs to the data warehouse, or today it's more likely to be to the data lake itself. We end up building very inflexible, rigid data architectures. They're difficult to change. It's difficult to modernize. It's difficult to introduce new technologies, new data sources, new data formats. And if I want to introduce a new technology or a new data source into my data architecture, my current data architecture, I'll frequently go and build a brand new data pipeline rather than modifying an existing one, because modifying existing ones cause lots of downstream changes and disruption. So effectively, over time, we've built up these very rigid architectures that are driven by replicating data time and time and time again. And it's very difficult to change them. And if I want to do something different, if I want to innovate, if I want to scale, if I want to get real-time data, it's actually very, very hard to do this. I put this up there as a bit of a joke, because I'm saying this is our resultant data architecture. It is that hairball that everybody talks about. The thing I actually like about this diagram, other than the fact that if you look at it for long enough, it makes your eyes go really funny, is it's constantly changing. It's constantly evolving. And that's like our architectures. That's like our data architectures. They're constantly changing and they're constantly evolving. And the evolving bit is a very important part of it. If you think about how a lot of people, when you go and ask them what does their data architecture look like, they will give you this nice diagram and it all looks planned. I always think of city planning, city growth, where conceptually people's data architecture looks like New York. It's this nice grid, nice orderly layout of streets and avenues, etc. The reality, most data architectures are more like London, which has grown organically. It's this massive intertwined streets that cross over each other, and there's no clear grid and structure to it. So most enterprise architectures, most data architectures have grown organically over time. Decisions that were made, which at the time were for very, very good reasons at the time. I'm not accusing anybody of doing anything bad, but decisions that were made a while ago for very good reasons have a longer term impact, which may not necessarily be obvious to the people at the time. Maybe if we thought that replicating data using ETL would cause these rigid architectures in 10, 20 years' time, we'd have thought of a different way of doing it, but we didn't know at the time. We didn't know how things are changing. So all of this rigid architecture actually has a business impact. You know, as the Rolling Stones put it, who wants yesterday's papers? Because we're replicating data, we're actually delivering it slowly to the business. We're not allowing the business to get the data they need. It's not real-time data. Because we're replicating the data time and time again, every time we want to get the data for a new project, for a new report, we go and create another copy of that data in a data mart or something like that. It's slow to work. It's not scalable if we have to replicate the data all time and time again. We need to get the data to the users of that data quicker than ever so that they can get insights, they can get value from the data. And the ongoing pandemic has made companies realize that they need to be more agile. They need to be able to pivot their business model and business operations based on changes in the economic circumstances. Just think of back in April of last year, how quickly high street retailers had to change their operating models due to lockdowns. Their stores were closed, so they very quickly had to move to online models and home delivery. And I remember talking to an architect at Marks and Spencer's, and he was actually saying that as they were closing their stores down, the online orders for their food products shot through the roof, and they had to very quickly change everything to online delivery of foods. They weren't too bothered about online delivery of clothes at that time, because if they couldn't deliver to meet the demand, Tesco's or Waitrose or Sainsbury's would step in and take away their business. Banks had to do the same. Banks were actually creating new loans and new loan products actually on the fly in response to the demand for small businesses under the job retention scheme in the UK or the payroll protection program in the United States. So the question is, how do we make our data architectures more scalable, more real-time, and more adaptive? That's the challenge we face if we're going to allow the business to be able to move and evolve quick enough, to innovate quick enough to take the best value from this data. Fortunately, we actually have the blueprint of this from the hardware side of things. Virtual machines, containers such as Docker really have given us a path forward. They give us an insight into how we can actually move forward with data architectures. Virtual machines and containers isolate applications from the underlying physical hardware. Both containers and virtual machines are virtual or logical infrastructure and provide this abstraction layer on top of that physical hardware, which makes it easier to deploy them, manage them, scale them. And we're actually seeing this in the data architecture world. Obviously, virtual machines and containers are more about the application architecture side of things, especially containers. We're seeing this in the data architecture side of the world. We can use virtual or logical architectures to decouple data analysis, data usage from the physical data repositories themselves. This decoupling allows us to be more flexible. It allows us to access data more quickly, including real-time data now. And we'll talk about that in a few minutes. It allows us to innovate faster, allows us to introduce new technologies, new data sources, new data formats. And this is something that Gartner, analysts such as Gartner, et cetera, have been talking about for quite a while, how data architectures are evolving towards logical architectures, virtual architectures. We tried consolidating data into single repositories. We tried this with the data warehouse, put everything in your data warehouse and you can go and get all the data you need from the data warehouse. And now you can do anything you want. Well, that didn't really work. Now we're building data lakes. The idea was that you throw all your data into the data lake and everybody can access the data from the data lake. We can do all wonderful things. Data lakes are multi-structured, multi-format, multi-model, polymodel. structure, so I can put any data I want in there. Then the data scientists can dive into there and do all these wonderful analytics, be innovative, etc. That's not really working either. Now, we keep trying it, but it doesn't really work. I mean, we've already got organizations that we're working with that have got 13 data lakes. They were thinking of building a 14th data lake to consolidate the first 13 when they thought, well, maybe this is not the best way to think about it. So the concept of logical architectures come into play here. Instead of replicating the data, copying the data, you leave the data where it is, and you provide everybody with an access layer. So when Gartner talked about the need for logical data architectures for modern analytics platforms and logical data warehouse in particular, the idea is that instead of building a single consolidated repository that contains all the data that we need, instead of building that 14th data lake, you leave the data in its native or natural repositories. It could be in a database, it could be in a data warehouse, it could be in the MDM system, a data lake, and so on. And you build a virtualized access layer to allow people to find and access the data that they need. So instead of copying the data to yet another centralized repository, in other words, that 14th data lake, you start, instead of collecting the data, you start connecting to the data where it lives. As Gartner put it, stop collecting, start connecting. The virtualized data access layer becomes the place where users go to find the data and access the data they need. They're not hunting for the right data. They're not begging permission to connect to it. They're not fighting the technology to be able to actually read the data, use the data. They just connect to this data access layer, and you get the data that you need. And this is where data virtualization plays its role. So the idea is that if you want to make it easy for people to find and access the data they need, to allow them to do their job, to allow them to innovate, to allow them to come up with new ideas, new products, make it easy for them to find the data. Also do it in a way which allows them to get to the data as it's stored, real-time data if necessary, coming up. You shouldn't have to copy your Salesforce data into your data lake just so people can access it. They can access it perfectly well from Salesforce itself. You just need to give them the ability to do that. You need to change the way you think. So if we think about very quickly how data virtualization works, data virtualization allows you to connect your data sources, whatever they are, whether they're databases, whether they're applications, on-premise or SaaS applications, whether it's your data lake, your data warehouse, etc., data in files. We still have lots of Excel files floating around with important data. So connect the data where it's actually stored. The source of the data, not the copied version that you've got in your data lake or your data warehouse. Connect to where the data is. Then you can define how that data should be combined to build something that is useful and meaningful to your users. Now, these are virtual views that we're building. And then your users can actually connect to those underlying data, to the data virtualization platform, using the tools that they're familiar with. So reporting tools, applications, etc., through REST APIs if you want to build a web app. And they can go and request the data from the data virtualization platform, send a query to get the data from the data virtualization platform. The data virtualization platform will actually go and get the data from the live data sources. So from Salesforce to get me my customer data, from the finance system to get me my billing information, from my remedy trouble ticketing system to get me my information about how the customer has interacted with us in the call center, etc. Pull all that together and return the results back up to the user. So the user doesn't have to go and find and work out where the data is stored. It's presented to them on the plate. Now they've got the data. Now they can do the stuff that they're very good at. Now they can do their jobs. Now they can look at better ways of using that data. So data virtualization, in a nutshell, allows users to connect to data where it's actually stored, connect to the data sources itself, allows them to define how the data should be combined and transformed into the format that's needed by the actual consumer. And then the data can be exposed to the user and they can connect using their existing tools to actually get the data that they need so that they can do their jobs. They can be innovative. They can come up with new ways of using that data. And all this is done without moving the data, without copying the data. So they're getting the data from the source. So real-time data where necessary, historical data from the data warehouse where necessary. It's that mix and match. So what this does allow is the data virtualization layer, the data access layer, becomes an abstraction layer, effectively. We talked about containers, we talked about virtual machines as well as being the abstraction layer on top of the hardware, the infrastructure that we're running. Data virtualization becomes an abstraction layer on top of our data sources. And this abstraction layer has very, very powerful effects. It's a very good thing, as we've seen with containers and virtual machines. It isolates one side of the equation from the other. In the case of containers like Docker, it isolates your coded logic, your Python script or JavaScript or something like that, from the physical infrastructure. In the case of data virtualization, it isolates the users from the physical data repositories. And that gives either side of that equation the ability to have more flexibility, more freedom. So on the user side, it means that they can pick and choose what tools they want to use. If they want to introduce new tools, they want to introduce new ways of using that data, writing some machine learning algorithms or using AI or something like that, well, they can just plug those tools into the data virtualization platform using standard protocols, standard formats, and they can access the data that they need. They don't have to go and conform to whatever diktat comes from IT about what tools you must use Cognos to do your reporting. No, you can go and use Power BI, you can go and use Tableau, you can go and use SageMaker to do some AI, etc. On the IT side of things, it now gives IT more flexibility into how they manage and control and optimize that infrastructure. If they want to migrate data to the cloud, they can do, because the users are not accessing that physical data repository anymore. They're accessing it through the data virtualization platform. So if I want to migrate my data warehouse up to Snowflake, I can do that. I just move the data, repoint the data virtualization platform. Instead of getting the data from the legacy on-premise Oracle database, I now get it from Snowflake. So from the IT perspective, I can start optimizing and modernizing that IT infrastructure. I can start to introduce new data sources. I can introduce new data formats, but the data virtualization platform will make it available to users in standard formats. And I always use the example here of trying to read a Parquet file into an Excel spreadsheet. The data virtualization platform makes it very, very possible. I connect my Excel spreadsheet to the data virtualization platform using the ODBC connections, and the Parquet data is there for me as this virtual view. When I go and read that data, load it into my Excel spreadsheet, the data virtualization platform takes care of getting the data from Parquet. I don't need to do that from Excel. So it allows me to get to data that maybe previously I couldn't get to. Now I can do different things. Now my Excel spreadsheet and my pivot tables can do all wonderful things with data coming from Parquet files, which previously I couldn't do. Also, one of the big buzzwords at the moment is all about, sorry, I've just blanked on it. Data mesh. Sorry, I totally blanked on the word there. I apologize for that. One of the big buzzwords is around data mesh and the ability to build these distributed architectures. And that actually falls very nicely into data virtualization as well. You can actually have your domains, your data mesh domains, owned by the different domain owners within the data virtualization platform as well. So it really does promote this idea of being able to distribute the workload, make the domain owners, the domain experts, the owners of the data for finance. In this situation, our finance domain would be owned by the subject matter experts from the finance organization, and they would be responsible for exposing the finance data through the data virtualization platform connected back to their finance systems, their finance data sources, etc. So they would own that. They would be responsible for maintaining that. So this concept of data mesh still applies even within the data virtualization platform. So this really does give you that flexibility to come up with these more innovative, more modern architectures, moving away from the legacy copy the data everywhere type architectures. The benefits of adaptive and flexible architecture using data virtualization for the business users, it's simplicity. I don't have to spend all my time hunting the data. I can go and get the data from the data virtualization platform. And whether it is on-premise, whether it's in the cloud, whichever cloud it's in, I have one place to go. So I can support these hybrid multi-cloud architectures using data virtualization. The users don't need to worry about where the data is physically located, how to physically access that data repository and get to the data. The data is available through the data virtualization layer. Obviously, you can therefore expose a lot more data to the users, give them more accessibility to their current tools. You can build a common understanding of the data so that everybody's using the same semantic definition of the data. This is what a customer is. This is what a financial instrument is. That definition is all then codified within the data virtualization platform, giving everybody the same view, the same understanding of the data, which obviously increases governance and all these good things there. From the IT perspective, obviously, having this abstraction layer, isolating the users from the physical repositories, gives them a lot more flexibility in terms of managing that infrastructure, modernizing that infrastructure, being able to control it, being able to introduce new technologies, being able to deliver data faster to the business so the business can innovate as well. It just gives them that flexibility, that isolation that we've seen so well in virtual machines and containers now is available within your data architecture as well.